Morning. I'm going to explain to you the lab where we're going to practice drawing vectors to scale using a protractor and a ruler. So you're going to need those handy, as well as a sheet of paper. Lined paper is better, but it's not critical. So I'm going to explain to you the lab, I'm going to give you the data, and I'm going to kind of get you started with using the protractor and ruler so that you feel like you can be successful. If you ever have questions, make sure you ask. So the problem look at is if we start from my room, right, the middle of the hallway where the two hallways intersect, that corner, I want to know what is the distance and displacement to the front of the elevator doors. So there's two different ways we can walk from my room to the elevator doors. We can head down to Social Studies English Hall towards the library, then make a right-hand turn, and I'll go past the atrium and we're there. So that's one route that we're going to get data from. The other way I can go is down to Science Hall towards chemistry, make a left down to Social Studies Hall, and then there's a slight little turn right around Mr. and Mrs. Josephi's room, and then there's a little diagonal there. And you end up at the same spot. So I'm going to give you data for both of those routes. So I've explained this one and I've explained that one. And you're going to draw those routes given the lengths to scale, and hopefully you end up at the same spot when you go to draw your vectors, displacement vectors. Okay, so I'm going to give you the information. So what we did is we walked off the distances and counted steps and said each step was a meter long. We actually looked at tiles and it helped guide us. So our data is not too bad. It's actually fairly accurate. And then there's one angle that we had to measure, and I'll try to sketch it for you right here. Okay, so route 1 is going down this simplest one, headed towards the library and then making it right at the atrium. And so if we measure the different segments for that, we see that the first segment is a long segment, and that's 83 meters. And then if we make a turn, we measured it to be 28 meters. If we go down Route 2, which is the science hallway, all right, there's 3 segments there. There is a 57-meter segment, then there is a 32-meter segment, and then lastly a 58-meter segment. And then there is an angle in the hallway that corresponds to the transition between here and here. And that is 33 degrees from the vertical. Okay, so I'll have to explain that in a second. But the vertical means if I was walking down the hallway, I deviated 33 degrees from that direction. I had to kind of go left of forward. So what I want you to do right here is I want you to sketch the 2 routes. I'll sketch route 2 for you. Based on what I described, you should be able to sketch route 1. Okay, so you're just basically making clear what you're going to be drawing. So route 2 is this. This is 225. I headed this way down Chemistry Hall, and I'm putting an arrow there because indicating the direction I walked. Then I turned and went up a little way. And that was my second segment. And then I deviated, and I'm going to draw a little dashed line here. And then I deviated this way another 58. And what this is the 33-degree angle here that I was talking about, okay? So I deviated 33 degrees from that. So your goal for each route, especially this route, is to find the distance from here to here, right? A displacement for those 3 vectors is from the beginning of the first to the end of the last. So don't draw this in now, but that's the length you're trying to find and the angle you're going to try to find, that magnitude and direction. That's our goal, and you can do the same thing for route 1. You can sketch that. Remember, that was just a right angle turn, a right-hand turn. Okay, so you can fill out the chart here. The distance is pretty straightforward. The displacement is what you're going to have to draw to scale. So I'm going to try to explain for you the analysis without doing it for it. You're going to use this analysis you're going to do later. You're going to do the same thing, okay, just for route 1. I'm not going to ask you to do it for route 2. I'm solving for the displacement using geometry, Pythagorean theorem, and trigonometry using the tangent one that we saw in the notes. But let me explain to you how to do analysis 1, which is explained right here, okay? So I'll try to explain it, but 1, 2, 3, you should be able to follow directions. I can't clearly do this with a protractor and a ruler on the smart board, but I can try to describe to you what you should be doing. So let me go to a blank page. So imagine you now have a blank paper in front of you that's oriented normally like this. So you want to draw to scale those distances for each route. Since the elevator is here and we're starting here, okay, you're going to want to start your vectors right here. So you're going to choose a point. If you have graph paper, that's the best thing to use because it's just easier. But if you don't, you can still do this. So what you're going to do is, in order to draw to scale, you have to choose a scale. So we got to translate the lengths we draw on paper to the actual distances we walked. So we measured everything in meters. So let's say our first segment for the hallway, Route 1, was 83 meters, right? Well, we're not going to obviously draw an 83 meter long line, so you might say, okay, 1 centimeter of paper is actually 1 meter of walking distance. If you say that, then you'd have to draw a line that's 83 centimeters. Well, that's not practical. That's going to go off the paper. So we have to choose a more appropriate scale for the length of our paper. Probably the easiest thing to do is you might say 1 centimeter of paper is equal to 2 meters of walking. That would reduce our paper distance to about 40 something. Still a little long. So let's say somewhere on your paper, write the word scale, maybe up here. And let's say 1 centimeter, that's what you're going to draw on paper, is equivalent to 5 meters of hallway distance, or what you walked. Okay, so what you would do is you take this number, the actual distance, you're going to divide by 5, and that gives us 16.6. So you're going to draw a line segment that is 16.6 centimeters long. So you're starting here, you're going to label this as room 225, and you get your ruler out, you measure it and make sure it's perpendicular or it's parallel to the sides here. So if you need to use a protractor, if you have a blank sheet of paper, do that. I don't want that angled. I want it to look good and accurate. But anyway, draw the appropriate length, put an arrowhead on it to indicate that's your displacement vector, and label that 83 meters. Then you got to do the second segment for Route 1. Well, you're going to start from here, and you're going to go over, and you're going to draw the second segment to the correct length, label it. I think that was 28 meters. So that's first route. So now what you would do is you want to find a displacement. The displacement is the vector sum of these two. So since we drew it to scale, we can line up our ruler here, draw a line, that's the sum of those two, that's the resultant, and label that. You can label that R, resultant, and then measure its length in centimeters, and then use the scale to convert to meters, or to actual walking distance. Before you start Route 2, then you want to measure the angle. You want to measure this angle theta with your protractor. So I'm going to try to simulate this to help how to use a protractor. So what you do is, if you have a protractor, right, hopefully you got one from picked up, it looks like this. Okay, I'm not going to draw the inner part, but there's a little crosshairs right in the middle. You're going to line that up. So what you do is you line that up right here, and you line the base of the protractor this way. You turn it sideways so that the semicircle looks like that. Now you can measure over this angle right here. Okay, so it shouldn't be a big angle. It should be between 10 and 30 degrees. Now you have to do 2. So with 2, you're going to draw a segment over here. You're going to measure the scale. You're going to do the same thing here. And then you got to go over 30 degrees here, 33 degrees. So with your protractor, you once again line that crosshairs, the middle of that along here, put the base along here, and you're going to measure up or over this 33 degrees and draw out the correct length. Ideally, if everything were perfect, this segment would end at the same spot as here, but it might not. Don't force it to, so it might end right there. It's close to the other one, as we'd expect, but not exactly the same. And then you're going to draw its own resultant. I know this is getting really messy. So you draw that one, call that R2 or whatever, measure the angle and the resultant, and the length, put that in the chart, and then you're going to do the geometry one the second way. Okay, so hopefully I've made it as clear as I can on paper, so to speak. If you have questions, make sure you ask.